Hello and welcome to lesson 15 of Software Design and Development for Higher Computing Science. Today we're going to take a look at finding minimum and finding maximum, the next two standard algorithms in the list. So here I have a program, and all it does at the moment is it gets data from a text file and it stores it in two parallel arrays. So we're not using a record structure today, so we're going to use two arrays, one for names and one for ages. So look at what the program does so far. All it does is it gets the names and the ages from the getData function and it prints them. Here they are. You can see some pretty cool names and ages in there. So the two functions we're going to look at today, we're going to find maximum. Now finding maximum is just the formal name for any algorithm that finds the highest number in an array. So we have an array of names here, so we want to use this to find the oldest person. So let's rename it. Instead of finding maximum, find oldest. And in order to find the oldest person, all you need is the ages. You don't need the list of names to find the oldest person. You only need their ages. Now the finding oldest algorithm is actually quite simple, especially once you've seen it a couple of times. It makes perfect sense. And all you need to do is have a variable that stores the oldest age in the list. And initially we're going to set it to the first name in the list, because what we're going to do is loop through every age and we're going to check, is this age bigger than the one I have? If not, we skip it. If it is bigger than the age we have, we store that one as the new oldest. Then we'll go to the next one. Is this one bigger? Yes, we store that as the oldest. Is this one bigger? Yes, we store this as the oldest. Is this one bigger? No, we skip it. Is that one bigger? No, we skip it. And so on until you're left with the oldest age in the list. Now this will work if you just want to find the oldest age. Let me show you how it works. So we've got the oldest age, and what we're going to do is for I in range length ages, we're going to loop through all the indexes in the ages array, and if the age at the index we're looking at is more than the oldest age that we previously found, then we set oldest equal to the age at this index. And then at the end we just return oldest. Now here's the thing, this is returning the actual age, for example 19. Oh, and the other thing I should mention is when you have a tie, for example there are two people who are 19, which is the oldest, it always sticks to the first one because the next one is not greater than 19. So we're sticking with the first one. But when you're storing the age itself, it doesn't matter because it's the same age, but it will make a difference when you're storing the index, and I'll show you that after this. So first of all, we're just returning the actual age itself. So if we go down below and we say oldest equals find oldest, and we give it all the ages, and then instead of printing all the names and ages, we print the oldest age is oldest. And what you'll find is it'll just return the number 19. There we are, the oldest age is 19. But you might want to know who the oldest person is, not just how old they are. So in that case, it's not just the oldest age you want to find, you also want to find where you found them. You want to know where they are. So in that case, you want to find the location. Now initially we're going to set the location to 0. Now the reason we set it to 0 first and not a -1 is because, well, there's definitely going to be at least an oldest person. And we're checking the first age first. So we set it to 0 because that's the one that we're storing as the oldest initially. But if we ever find an older person, we also store the location. So we store the age of the oldest person and the location that we found them in. And what we want to return is the location. Now we don't need to return the oldest age and the location because with the location we can find the age from the ages array. Let's change this to old location. And then instead of the oldest age, let's say the oldest person, and we'll say the name at the old location index. Let's close this. So let's take a look. We pass in all the ages, we store the first age as if it were the oldest, and we store that location as if it was the location of the oldest person. Then we loop through all the ages indexes, and if the age we're looking at is greater than the one we previously stored as the oldest, then that becomes the new oldest, and we store its location as the oldest location as well. Then eventually we run through the whole loop, and we're left with the location of the oldest person. Skipping to our main program, we've got the location of the oldest person, so we just use that location to get that person's name. Let's run it and see who we get. Liam. Excellent. Let's take a look. Is Liam 19? There he is. Liam is the first 19-year-old. So it's working. Now, some of you eagle-eyed people out there might have noticed that we're doing something that is slightly inefficient. We're saying that the first person in the list is the oldest person, and then we're looping through all the people in the array and checking if they're the new oldest person. So we're storing the first person's age and then checking if it's more than the first person's age, which doesn't make any sense. Why would you get this person's age and then check if it's older than itself? So we don't want to start this loop from 0. We want to start from 1 up to the length of ages. So this way we store the first person's age, but in the loop we skip the first person and only compare it to the second person. It's not a huge amount of saving, but every little helps, especially when you're writing big programs, and technically this is what the SQA would expect, even though they wouldn't penalise you for not skipping the first person. But it's good practice. Okay, so we've seen how to get the age, we've seen how to get the location of the oldest person. Let's see how we can do it using records. Okay, I've amended the program slightly. I now have a record structure to store the names and ages of all the people, one person at a time. And in my getData function, I've got an array of people. We create a new person each time, and we set their name and age depending on the data on that line. We add that person to the array, and then we return the array. So what we need to do, amend this so that instead of names and ages, we're storing all the people. And instead of the old location, we're going to store the old person. But we need to give it all of the people. So this is now taking in all of the people. So how do we change this? Well, oldest, in this case, is going to be the first person in the people array. Remember, the people array stores a bunch of person records. And each person record stores a name and an age. So now we don't need to store the location because we're storing the person themselves. And that person has a name and an age. So we don't need the location to find the name because the person has a name. Hopefully this will make sense once we run through it. So the oldest person initially is the first person. Our loop's going to look slightly different as well because we don't need to loop through the indexes because we don't need to store the location. So what we can do is we can store a person from the people array. So for each person in the people array, we want to check if the person.age is greater than the oldest.age. And if they are, we say the oldest is that person. And then at the end, we just return that person. Remember, this person is one person record in the people array. The people array contains all of the person records. So when we've got the old person, we just need to say something like, and let's use an F string to make it easier, old person.name is the oldest person at age old person.age. And I need to fix the capitalization. Bloop. So here's that line. So we found the oldest person and we're saying they are the oldest person at age and then their age. Let's run it. Bianca is the oldest person at 17. That is wrong. Did anyone spot the error? What a doofus. We're returning the person, but the person is the last person in this array. We need to return the oldest person. What a doof. There we are. There's Liam. Okay, hopefully that didn't put you off. Now the last thing I'm going to show you, and I'm not going to go through all of that again, but is how to make this so it finds the youngest. Well, it's almost identical, but instead of if it's greater, we check if it's less than. And you probably want to change variable names. Youngest, 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 and youngest. And then down here, young person, find youngest. So the only thing we've really changed is the greater than symbol became a less than symbol, and variable names became meaningful for what it is we're finding. We're finding the youngest person, not the oldest. So let's run it and see if it works. Beatrice is the youngest at age 12. Let's double check. Beatrice is age 12 and she is the first youngest person there. Quinn is also 12, but Quinn came second. So it took a while, but that is how you do finding maximum and finding minimum. Now it doesn't matter if it's a person or if it's a game or whatever it is, if it contains numbers, you can find the lowest number or the largest number using finding min and finding max. Hope you've enjoyed this one. I'll see you in the next one.